Sioux. It's a very successful company from Eindhoven, and I know that they use Julia. And Keith's talk will be how Sioux actually enables Julia in production, and how do they use Julia in a real-world environment. So a round of applause.
Oh.
Keith, the stage is yours.
Is it working? Yeah. It's very brave of you to brave the cold and the wind and the rain to be here. So yesterday we had Tom and I from Sioux organized a mini symposium, which was very serious, very much about what we need to get Julia going in companies. Today I want to keep it light, and I want to keep it light by starting with a simple question. Why are we here? Right, this is a very simple question, often pondered, and I don't want to get into the philosophical why are we here, I just mean why is Sioux here, right? So a lot of people here are presenting packages, a lot of people are companies centered around Julia. We are none of that, right? We are a service provider. We are a high-tech service provider, and we are kind of involved in the whole chain. If you want to make a product, if you have an idea, but the idea is not quite right yet, you can call us. If you need to develop some software, you can call us. If you need to have it put into an assembly line, you can call us. We do the front-end thing. And I'm actually, and Tom, from the Mathware department, which actually started out at the university, and we used to be called Lime. That's why we have this little mascot here. And we have and we were incorporated into Sioux, right? So we became part of the bigger company in 2011, which is widely being regarded a good move, and it enables us to really cooperate with the rest of the things. And our portfolio is centered around these different competences we have. And if we look back at this, oh, yeah, something's gone wrong in the animation there, but this thing, we tend not to get involved in this kind of final stage. We're at the beginning stage, right? So we're looking at agreeing an assignment, doing some pre-studies, some proof of concept stuff. Usually when it gets to an alpha release, that's when we say, yeah, this is as far as we go. This is the end of the road for us. For the Mathware department anyway. So that might give you an idea why we're keen on Julia, right? So we're interested in this ideation stuff. It's kind of the Julia ecosystem, but does it really explain why we hosted the meetup in January last year? Why we created this 200 person strong Hot or Not event April last year? Why we sponsored the JuliaCon? Small disclaimer, none of these people have anything to do with Sioux, but I love this photo. And why we're modestly sponsoring this conference, right? I mean, it might seem that we just love Julia, right? And but there's more to it than that, right? It's not we're a business. We have to make business. And the reason that we're so keen on Julia, I want to explain with a kind of surprising example. So in a moment, you might be very shocked. Actually, you guys might be shocked already, so I'll start with this. This might already shock you. There's a little MATLAB logo there. Okay, so everyone's still fine? Yeah, everything's still fine. But this is for one of our customers, and they have a machine which has to do some calibration once a day. And this takes on the order of a minute. And I think, well, could we do something useful during that minute? But fine, okay, a minute, we can just about live with that. But now they're making a new machine where they've predicted that they need to do this action every 15 minutes, every 30 minutes. And then the projection is that this machine is going to spend a lot of its time doing this calibration rather than doing the useful thing it's meant to be doing. I'm being a bit secretive here, sorry, but we can't share too much customer information. So this was a projection. Well, customer would not be happy if this would happen, so they asked us for some help, right? And so, well, how do you make MATLAB faster? So first of all, we wanted to create this, right? We want to make these lines nice and thin that the machine is still doing the useful thing most of the day, and they would be happy. And of course, we did this with, sorry, everything still okay? MATLAB Coder. Yeah. This was the choice that was made maybe outside of our control, but it's also something we have quite a lot of competence in. So we said, yeah, fine, we'll do a MATLAB Coder, that's fine. We'll also help you along with some how to set up your Git properly, include some proper documentation of the release strategy. Okay, so now you might be wondering, why am I telling you? Why am I telling you this, right? That's a valid question. The point is that what we're doing here is something that's fundamental to the reason why we think Julia is good. What we're doing here is we're helping the customer. For some reason, this is charted in nautical miles, but we're helping the customer get to some point on their roadmap this year, right now. Right now, they're happy. But next year, their roadmap is going to want to be there. And we want to make sure for our customers that it's going to be easy to get from this point to the next point. And if we give them something that's very closed and difficult to work with, they might be happy now, but next year, they will not be so happy. Okay, one thing you could say, they'll come back to you again and ask you again, but then we have a lot of work. And we don't want a lot of work, we're lazy. So the important thing that what we've done, in this case with MATLAB and Coda, and giving them a proper Git strategy with some documentation, is we've made it possible for them to keep iterating on the improvements. Or for ideally, of course, for us to iterate on their code. But and get a continuous improvement. This is something that I've dubbed an open deliverable. I've invented a new word. I'm very proud of myself. And the O is as in, everyone familiar with the SOLID principles? So SOLID is 5 software engineering principles that are, it's an acronym, or it's a bit far-fetched. So the O is maybe the worst one, because the O stands for open/closed. So the O stands for half of something but the O means open as in open for extension. So the thing you write in software should be open for extension and closed for modification. But our deliverables should also be open for extension. And this means when we deliver something, it has to be workable. And workable means it has to be workable by the people we're giving it to, has to be workable with the tools they have at their expense, and has to be workable within the time that they reasonably have. And this kind of fills into something that, to me, was a bit of an eye-opener the first time someone said this. It's probably Uncle Bob who said this. Software must be soft. That's why it's called software. It's meant to be malleable, changeable, updatable, whatever. You should be able to do stuff with software. And to further labor the point, I got my kids involved, because that's why you have kids. And I asked my son, 6-year-old, to build a tower out of blocks, and he built this tower. I said, yeah, that's nice. And this is what I would call a very non-open deliverable, very closed deliverable. Just imagine trying to change anything here. You don't really know when it's going to collapse entirely, or what's useful to the construction, what's not. If you look carefully, you can even see the top blocks actually leaning against the wall. So I asked my son to do better, because that's what a real parent does. No, I'm not what that means. So I asked, well, maybe we should use this other toy we have, right? And here we have a lot of nuts and bolts. And we built this tower that's sturdier, and it's you can change it, right? You can unscrew some stuff and screw it back together again, but you do need some tooling. So then, of course, in the end, we always get down to our favorite toy, which is Lego, in this case Duplo. And we built a similar tower, but this one's really easy. You can just take it apart, put back together. You do all kinds of stuff with this. And I think, by analogy, what is our favorite toy in the room? Julia, of course, yeah. Yeah. So, if Julia's our favorite toy, can we do the same thing we did with MATLAB Coda with Julia for our customers? So I'm going to take you through some cases. I hope this isn't too salesy or braggy. Actually, it's not that braggy, because the first one we didn't actually, no. So this is for ASML. I am going to mention who this customer is, because this is, it's not a secret that ASML is doing Julia. And they have this inner source code base, right? And inner source is a bit like open source, but within the company. So it's software that's available to everyone within ASML, maybe except customer services, because somehow nobody trusts those guys. Sorry, I shouldn't be saying that. So careful with all the slides. And I'm not sure if you're familiar with the onion model. There's this notion that when you build software that you try and keep your object model, so your representation of the truth, very central, and that doesn't depend on how you're using it, but how you use the software depends on the truth and not the other way around. And the inner source tends to be centered around this middle. And this is actually one thing where I think the Julia package manager already really helps, because it makes it a lot easier to have different packages hosted by yourself. This code is shared by many different developer teams, and the goal is to get the quicker time to market, right? So this will pop back again. You can do almost anything with any tool. But with Julia, the idea is that if someone has a cool idea, they can type it out, someone else can modify it a bit, and then you can create an application, which should be quickly, so your customer is happy quickly. I think this is actually one of the key concepts that's driving Julia at ASML. A second case is something we have in-house. This is Sioux's most successful asset. So this is a piece of software we own that we sell to many different customers, especially to people who are shipping expensive stuff and shipping it fast. Like medicine is often shipped by air because it has to arrive fast because it can't stay too warm for too long. And then if you're traveling by air, you have to pay by volume when you're sending something, not like the typical Bol.com or Amazon order where you get this huge box with this tiny thing inside. Here we're really trying to pack the box as tightly as possible. And we have this thing that actually consists of two parts. It says, given a box, and the items, how do I stack them? And then on top of that, given the items, which box should I choose? And we have this in Java, and it's awesome. Definitely, if you're in this kind of situation, anyone here, check it out. Cubic Select, Districts is the product name, or Sioux. This is the thing you want. But here, again, we have this problem. Our customers are annoying. Well, not really, but they do have a lot of wishes. And different customers have different wishes. And sometimes these requests can be really urgent, right? I don't think it really happened, but I mean, this example, but imagine there's some new vaccine out and you want to ship it around the world quickly and efficiently. Maybe you suddenly have this need for something new, right? We have a lot of interesting stuff. Like most things are modeled as boxes, but occasionally you have something that's actually like a plastic packaging and you can stack them in a different way and you might want to use that. So lots of stuff is going on here. So we decided, well, of course, what we want to do. So the risk we run is that the number of features the customer desires is we can't keep up with what we deliver. So we thought, well, for faster prototyping ideation, tiny subtle changes between this animation, .jl. We created our own Julia version of this to do some rapid prototyping. We did accidentally introduce a two-language problem. But I hope to solve this by eventually killing the Java implementation, but that's a long way down the road. But this is I'm very happy with, because the Julia code that's been written here by a colleague of ours is actually really a nice playground for new people starting with Julia, in our company anyway, because it's proprietary, of course. Then the next problem is about a very complicated machine. Again, not naming the customer. I've used this example. This is one of my favorite books, also one of my son's favorite books. It's about a very complicated machine, and in this case, we're trying to optimize. So this machine has lots of nuts and dials and stuff you can twist and adjust. And you also have you have a high-dimensional actuator space and a high-dimensional target space. In this case, the machine is trying to pick elderberries off trees, which is also quite difficult. And there's these equality and inequality constraints. And again, here, importantly, there are tight speed requirements. This has to be fast, right? We're doing this online. Something is happening in this machine, and it's happening really fast, and we have to keep up with our optimizer. And then during a presentation about this, a colleague of ours showed this slide. So this is a blatant steal of his slide, but I think it really illustrates well, at least it's a starting point, what is so great about Julia. This is right, preaching to the converted here, but what it allows us to do is we can, well, I'm not sure which one you start with, but that's the whole point, I guess, but you can increase your model complexity and then make it faster And once it's fast enough to work with, you can increase the complexity again. And then you get this kind of picture where you go from left to right, from not many features to many features, and bottom to top from being slow to being fast. Every step to the right is adding a new feature, maybe at the expense of being a bit slower. And every step up is saying, hey, I have this new feature, it's good, I need it to be faster, and then you're implementing it. I'm going to also nicely join in on Michael's bunnies and cheetah. So I'm not sure if anyone attended yesterday's talk by Michael about the 1.5 language problem. If you didn't, go online in the break and watch it. Bunnies are the naive Julia implementation. A lot of allocations, a lot of accidental, type instabilities, that kind of stuff. That's what the bunnies are doing. The cheetah is writing alloc-free, immutable, writing the super fast Julia, right? And there's this trade-off. And what I think is essential here is that in many other languages, you could have the dots at the bottom right, or the dots at the bottom at the top left, right? You could have those four or those four. So if you're doing it pure Python, not that anyone ever does anything pure Python, you would have these 4 dots. If you're doing it in C++, you would have these 4 dots. Because what you're doing down here is probably not even feasible code in a strict language. And this is why our colleague, who, I won't name him, a different colleague to the one who was on the slide, his name's not anywhere. I don't like Julia, but I have to admit, for this project, it is the right choice. And this is kind of good. So if you have competent people saying this, because he's, I think, our most competent software engineer in the department, it means there's something good about Julia, right? It also suggests that the reason he doesn't like it means there's still a few things wrong about the newcomer experience to Julia, but at least we're really showcasing here that the language has a lot of value. Yeah, so these are, if you were to use C++, you'd probably have to somehow make those purple line jumps, which is probably impossible. Another benefit is if you use Julia and your iterations are faster, instead of doing this during the week, you start off your week like this, you continue your week like this, and by today, you're done. So you could all start taking your favorite hobby, which in some of us cases would be solving a Rubik's Cube. If you do like solving Rubik's Cubes, we have plenty of them at our booth. And the final case is, I'm sorry, I have to be really secretive here, so it's just called suspended droplet CFD, top secret, which is a case where they're doing some simulation in star CCM. Post-processing is done in MATLAB, and that means manually discretizing ordinary differential equations and then slow time stepping in the order of minutes, maybe towards a half an hour kind of time. And of course, that's no good, so we got in Julia, time integration automatically via Chris Rokokas's awesome SciML stuff. Or not SciML, I don't know what the exact name is, but it's done automatically, and it's razor fast, just takes seconds. The customer's blown away. So we're managing to build these bridges between what we're doing and our customer's roadmap in Julia. Okay, I am running out of time already, but the thing I'm actually more proud of at the moment is not the fact that we're building these bridges to our customers' roadmaps, but it's the internal bridges. So I started off this talk about Sioux and the Mathware department. It's a happy marriage, I think, but we're a bit disconnected sometimes, and I think it's fine for us to do our own thing. But at the moment, Julia is really turning into be something we can gather around. Wait, I'm going to skip this, right? So the Mathware department, we have these kind of, this is our core, right? We're about algorithms, about doing stuff fast. And the software department is about maybe the more serious, long-term way of working. But we're really finding each other in this Julia language because we can both work on it. We can both do our thing together. So a few weeks ago, Tom and I gave a course with the package called forsoftware.jl. This course is called Julia for Software Engineers, which was a good clue to whom we were attending. And at the beginning of the course, we asked these people, yeah, what is your favorite language? So we got C#, a lot of C#, we got C++ and Java. And we hope to have convinced them, well, I know we've convinced them to also think about Julia, because, well, so Johan back there is one of the software engineers who took this course, and now he's here. Yesterday we had 2 others here, and on Wednesday there was another one, so it's definitely working. We're indoctrinating people successfully. The course is much appreciated. To name some feedback, a practical, well, this is really bragging, but we also had a colleague who said this, it is quite useful, which I think is the nicest compliment. And why I really like us getting together as software people is to kind of break Conway's law. So instead of these separate teams working in their silos in their own language and having this real disconnect between what you're doing and the final product, we can move towards a situation where as a team, because you're using the same language, you're all working on the same thing. You can really see how what you're doing is connected to what the others are doing. And I think we're already experiencing this in some of our projects. That brings me on to our conclusion. So this is not really a conclusion of my talk, but I think something people need to realize maybe a bit more about doing software development in the real world is we're always aiming at a moving target. Our customers want to increase their roadmap, or they want new features all the time. They're a bit annoying in that sense, but they do pay us, so we're happy. And what we want to do via Julia or other ways is to be agile by having these open deliverables. We want to have faster product iteration. Again, Julia an ideal tool. And we see Julia also as a way to create stronger teams by having people more bonded together about things. I'm going to leave this up and take any questions if there are any.
Thanks, Keith, for a great talk. Do we have a question? Do I have questions from the audience? Okay, well, people are thinking. I have a question. Yeah. So, this colleague of you, why he didn't like the language and why it was actually the right choice after?
So why it's the right choice was because I think he also sees in any other language you wouldn't be able to do this combination of where you're iterating, and during the iteration you already have to know that it's going to be fast. You can't just develop something new and hope that after someone else has translated it, that it's still fast. And the reason he doesn't like it, I think, is for I think maybe it being a bit too dynamic for his liking. There's some things he really misses, maybe. I think he mentions a few times, like, functions have a type, but not a type that bounds them to their input and output argument, signatures, something like that. And in general, I think also we may have let him loose on Julia a bit too much, and he started to do his own thing, and maybe he didn't quite follow the idiomatic route, which has caused him some pain as well.
I see. And like, how big is the team that uses Julia in Sioux?
It's only about 6 or 7, I think. There's quite a few people who have used Julia, but it's not a continuous thing. And
what is like maybe the biggest challenge to convince people to use or to try a new language?
I think it's the newcomer experience. So within the Mathware department, we're centered around a lot of Python, and we use MATLAB a lot because our customers sometimes have it as a requirement. And there, when you get started, everything's really easy and really friendly, and the internet is full of tools on how to use it. And when you get started with Julia, there's a few roadblocks. I definitely want to recommend Michael's talk because he mentions the survivorship bias as well, which is a problem. Us here, we don't know what's killed off the other guys who aren't here, right? There's a lot of empty seats, and they could be filled with people who, for some reason, have given up on Julia.
It's funny that you mentioned it because I wanted to have a follow-up question. Like, in your opinion or experience, what would be like the key thing that Julia needs to invite more newcomers, to become newcomer friendly? Maybe
yeah,
it's like
I find this hard to say. I feel like I feel like the IDE might be one thing. There are some things that are bit missing there, maybe.
Anyway, thanks for the great talk. Extra round of applause. So our next talk will start in a couple of minutes. So yeah.